All of you. Uh, I hope you practice the two types of inheritance so far what we discussed in previous classes. So in today's session, we'll go with other type of inheritance, that is multi-level. Multi-level we completed. We'll go with the multiple inheritance. So first of all, what do you mean by multiple inheritance? Already we seen single inheritance and multi-level inheritance. Uh, Multi-level, we have multiple levels, like we have like a grandfather class, and father is derived from grandfather, and we have child class, a child is derived from the father. So like this we have multiple levels, but in multiple inheritance, we have multiple base classes, and from these base classes we will derive the derived class. Okay. So this is a simple definition of multiple inheritance. So let me give some simple example so that you can understand what do you mean by this multiple inheritance. So I'll give you some pictorial representation of multiple inheritance. So we have base class 1 and base class 2, and similarly we have base class 3, and so on. We have like this some other base classes. So like this we have multiple base classes. From these multiple base classes we need to derive derived class. So here we can consider this is base class 1, and we have base class 2. Like that we have multiple base classes, and from this base class we need to derive the derived class. This is base class 3, and so on. Base class n. From this n number of base classes, we'll have uh, derived class. We'll derive the derived class. So there is a concept of multiple inheritance. So derived class here in this level, I know the derived class. Okay. So this derived class is derived from multiple base classes. Okay. So from this multiple base classes, we'll have this derived class is derived. Okay. So this is the simple concept of multiple inheritance. So now we'll see some programs for this multiple inheritance. So how it is going to be implemented, we'll see some example program. So actually we are discussing about different types of examples mostly on student example, we are seeing some programs on inheritance, even in single inheritance, multiple inheritance. Also, we'll discuss the same student example, even in multi-level also, we see the same example. So before going to that, let me write the syntax of this multiple inheritance. We have a base class here. So class uh, base 1, and from this base class, so we declare one more base class, class base 2, and here it is also having some statements. Like this, we have multiple base classes. Like this, we have multiple base classes. Class base n. We have multiple base classes are there. So each and every base class is having its own definition. Now we need to derive the derived class. So class derived. We need to derive this derived class from base 1, base 2, and so on, base n. So this is the definition of derived class. Okay, and once we have this derived class, then we can write your main program. So you can write your main program. This is a simple syntax of multiple inheritance. So we have different base classes. So from each and every base class, we can write some statements and some functions in each and every base class. As we know already, a class consists of methods and as well as data. So in base class 1, you have some methods and data. In base class 2, you have some methods and data. Like that, we have n base classes. And once you define your n base classes, and you need to have some derived class. In the derived class, what we'll do? The derived class is derived from n base classes. So that is what this inheritance is all about. So, which type of examples we can use while implementing this multiple inheritance? Let's see some examples. Let's see some 1 or 2 examples so that you can understand how this is going to be implemented. Let me write some simple example first, then we'll go for some complicated example. Okay, so let me declare some class student1. Okay, so here I can define some method, define m1. M1 is nothing but it's a print. This is base class 1. Next, similarly, I can define class m2 student2. In student2, I can define m2. So in m2, I'll define print. This is base class 1. So like this, I can define one more base class student3. So here also I can define m3. So here I can define print. This is base class 3. Base class 3. So now I defined 3 base classes. I defined 3 base classes, and once this base classes are defined, then we can have your derived class. Okay, I can derive some derived class. Okay, I can write student 4. Student 4. The student 4 is derived from student 1 and student 2 and student 3. So these all are the base classes. From these three base classes, I am deriving this derived class. Here derived class is student 4. So in this I can write define M4. So in M4, just I can write it is a print. This is derived class. This is derived class. Okay, so this is about a program, and now I need to define the main. Okay, now I need to write the main program. In main program, just I'll write. I'll create some object for what, for the derived class. So I can create S is equals to student 4. So this is the object. S is the object I created for the derived class student 4, and from this, okay, you can access. Okay, you can access all the information because the student 4 is derived from all base classes. So S dot M1, S dot M1, S dot M2, S dot M3, and S dot M4. So these are the methods. So here, so in general, we can have only one base class and one derived class if you are using a single inheritance. In single inheritance, we have only one base and one derived. Okay, in multi-level, we have one base class, one derived class, and that derived class is going to derive one more new class. But whereas in multiple, we have multiple base classes, and all these base classes are going to be derived from this. All these base classes will become the parent for this derived class. So that's why we are going to derive this student 4 from student 1, student 2, student 3, because student 4 is derived from this student 1, student 2, and student 3 with the help of student 4 object. What is the student 4 object here? So this is nothing but a student 4 object. S is the object for student 4 class. So what is student 4? Student 4 class is nothing but a derived class. So with this derived class object, yes, I can access the information of derived class and as well as the other base classes from which the student 4 is derived. From which the student 4 is derived? It is derived from student 1, 2, 3, right? So that's why I can access the information of student 4, student 3, student 2, student 1. Why? Because it is derived from that three base classes. That three base classes, student 1, 2, 3, are the base classes from which this is derived. Okay. So this is simple example. We'll see one more example also. So save this as multiple inheritance. Multiple inheritance 1.py. So now if you see here, we are able to access base class 1, base class 2, base class 3, and derived class information. Just I'll keep this side by side so that you can understand how we are able to access this. Okay. So this is the program and this is the output. So here we are able to access this all the base classes. So the base classes are student 1, student 2, student 3, and so on. Okay, if you want, you can create multiple base classes. I created only 3. If you required it, based on the application, based on the type of the problem you are working on, you can create multiple base classes. Okay, and from that multiple base classes, what you have in your application, you can derive a new class. Once you derived a new class, with the object of that new class, with the object of that derived class, you can access the information of all the base classes from which it is derived. So that is the uh, concept of multiple inheritance. So now we'll write one more simple example. I'm giving 2 examples for each and every type of inheritance so that we can understand better. I'm giving a concept, okay, using 2 examples. So, okay, so let me take one more example. So this is arithmetical operations example. I'll take arithmetical operations. So I can consider class uh, A. In class A, what I'll do is I can take some definition. Means I can define some function add. In add function, I can take 2 arguments. First argument by default self, and second argument num1, num2. So these are the 2 arguments I can consider, and return sum. Sum is nothing but num1 plus num2. Okay, next I can create one more class B. So in class B, I can define subtraction function. In subtraction function also, I can create self num1, num2. Next, return num1 minus num2. Next, we'll declare class C. In class C, I can define multiplication function. So here I can take self num1, num2. Okay, so here also I can have return number 1 into number 2. So I'm declaring different base classes here. So here I can declare one more base class B. Here I can define division. I have self parameter and number 1 and number 2. So these are the different functions, and here I can return is num1 by num2. So these all are the base classes, and I can take one derived class E, and from this class E, I can take A, comma B, comma C, comma D. So I took some 4 base classes A, B, C, D. From these 4 base classes, I am going to derive this class E. Right. So now here I can define, okay, floor division. So in floor division, again I'll take same argument self comma A self comma number 1 comma number 2. So here return number 1 floor division number 2. Okay, so this is about all the classes. I took 4 classes: addition, subtraction, multiplication, division, and in my derived class, I took floor division. Okay, so now I'll start main program. In main program, I'll create object. Okay, so object small e is object. I need to create this object small e for the derived class. What is the derived class here? E. Okay, and I can print all the information. Print dot add e dot add. Okay, for e dot add, if you want, you can pass some parameters also. So here I can read some numbers. Print number 1 is equals to int of input of enter any number. This is important program because it is little bit different and very important also. So let me explain in detail once. Okay, I completed this program. Enter any other number. Okay, so now I'm going to read these 2 numbers and I'll pass the same 2 numbers to my function. So here int add. So I can pass this 100 number 1, number 2. Whatever numbers I'm reading here, I can pass this number 1, number 2 to this function. And similarly, I can print e dot subtraction. Here also I can pass num1, num2. Next here also print e dot multiplication num1, num2. Similarly, print e dot division num1, num2. Next print e dot floor division num1, num2. Okay, so this is the program. Let me explain this program from line 1. So actually, most of you are going to think that the program will start from here. Okay, it is not executes from this line. Okay, all these are nothing but the class definitions. Class definitions we are going to write as per our requirement only, but the program from where these classes will be executed, the classes will be executed from your main. Main means here when we create an object, then only you can access the class. So that's why these programs, okay, you need to take care how the execution is going to take place. Okay, so here I created this main. Main is nothing but simply what I'm trying to access. So here this is object I created for capital E class. What is capital E class? Capital E class is actually the derived class. It is derived from 4 base classes. What are the 4 base classes? A, B, C, D. So A is a base class, B is a base class, C is a base class, and D is a base class. So from these 4 base classes, we can have one derived class, that is E, right? So that is the reason why for this E, I created an object. Okay. Next, what I'm doing, I'm reading 2 numbers. I'm reading 2 numbers, number 1 and number 2. So this is also very important. So far, whatever the examples we did for single level inheritance, multi-level inheritance, okay, we didn't took any input from the main. But this is the first example where I'm going to read input in the main itself. Okay, so here the input here we are reading from this main and print e dot add num1, num2. So what is this? When I write this line, what will happen? Okay, E is nothing but object for the derived class. And what about add? Add is a method where this add is written. Now from this line immediately your control will jump to this method. Which method? This method. Okay, from that line your control will jump to this line because add is defined here. In this way the program will be executed. Don't think like okay, your program will be executed from line 1, line 2, line 3 like that. It is not like that. Okay, that is the reason why you need to know the flow of the program, how this program will be executed. Okay, and how that function will be called. So that is what for example, already I showed you some example in my previous classes when we discussed about classes and objects. If I return pure classes only, I won't get any output because you can write 100 classes, you won't get any output because you are defining a class. Okay, but you are not calling it. When you call that particular class, when you create an object with the help of object, if you call that particular class, then only it will be affected. If you create, you are created because maybe you required, that's why you created. If I created some 100 classes, okay, it is not like I need to call this 100 classes. Maybe you can call that, or maybe you may not call it. That is depending on our requirement only. So that's why defining a class is not like we need to call it. We may call it or we may not call it also, right? So that is a so now what will happen here when I have this line e dot add num1 num2, immediately your cursor will goes to that line. So let me explain little bit better. Okay, so okay, so this is the program what we are talking about. So in this program, just I defined this statements, but as well our program execution will start from here. Okay, so whenever I have this line, okay, these are nothing but just I'm reading two inputs. But whenever I have this line, so what will happen when I have this line immediately? Okay, it will goes to the definition part. It will search for the definition part. So that's why whenever I call this line, it will goes to this add function where we are defined that add function. Okay, so to that function, it will be okay. It will be immediately your cursor is going to search for that function, and that function will be executed. Okay, so that is what we are talking about. So immediately, whenever you are going to call any function, it will jump to the definition part. Here I am calling e dot add. So whenever I call this e dot add, what will happen is it will search for its definition. Where it is defined, it is defined here. It is defined here. Okay, so this line will be executed. The statements will be executed. Okay, so once this is executed, and where the control will go again, the control will go back to again. It will go back to the line, next line. What is the next line? This line, e dot sub. So whenever I call this function e dot sub, what will happen? Again, it is going to search for the definition of this method, sub method. So, and it will goes to that line, and it will execute the statements in that method, and again it will come back here. Okay, and once it is came back, again it is going to call. Okay, mul. We are calling this multiplication function. So, and again, it's going to search for this MUL function or MUL method, and it will execute the statements in MUL method, and again it will come back. Okay. Next, we are calling div function. Then again, it will goes to div method, and it will execute the statements what we have in a div method, and again it will come back here. And finally, we are calling floor division method, and again it will search for floor division in the program. It will execute that statements in floor division method, and again it will come back to same floor division method. So if there are any statements after this, actually in our example we don't have any statements. So here the program will be stopped. So that is the way how any Python program will be executed. It is not like okay, in line number 1 I have this class A. So then I'll execute this from this line. It is not like that. It is not like from line number 1. That's why okay, if you are created some classes, it is not like all the classes whatever you created everything will be executed. It's not like that. Whatever the class you are going to call, that will be executed. So here we are calling add method. So that's why it's go to add method. And next we are calling subtract method. It will go to subtract, multiplication, division, like that. Okay, let me save this and run this program. .py. So it is asking enter any number. I am giving 6 and 4. Okay. So what is this? This is addition. As we are calling add function first here, let me keep this input and output side by side. Okay. So now, yeah, this is the program and this is the output. And here, if you observe here, first we are taking some 2 numbers. So in the 2 numbers, I am giving first number as number 6 and second number as 4. Okay. And what we are doing here, we are calling add, right? When I am going to call add method, what will happen? It is going to execute this method. So what is number 1? What is number 2? We given number 1 as 6 and number 2 as 4. So that's why 6, 4. So return number 1 plus number 2, 6 plus 4. So 10 will be returned, and whatever it is returned, here we are using print statement, right? Print of. Okay. So 10. Next, e dot sub. So we are passing 6, 4 for the subtract function. So what it is doing? 6, 4. So 6 minus 4, we are going to get 2. So that's why we are going to get 2 as the output for the for second function call. We are getting 2. Next, multiplication function we are calling, that is e dot mul of self comma number 1, number 2. We are multiplying 2 numbers. Next, we are calling a division function, that is 6 by 4. 6 by 4, already we know that in integer division in Python, it's going to return float. So that's why 6 by 4 is 1.5. Next, in the derived class, we are calling floor division. Floor division is 6/4. 6/4 is nothing but it is going to give us 1. So this is the way how this program will be executed. Okay, so the most important point in this program is this input reading. If you don't know how to read this input, then again you are going to face difficulty. So here, why I am reading this input number 1, number 2 here? Why not in some other place? Can anyone respond with your answer? Why I am reading that input number 1 and number 2 in that place? Why not in some other place? Please respond with your answers. I'll repeat my question. Why I am reading this input, this number 1 and number 2 values here? Why not in some other place? Please respond. You can respond in chat box because I want to see whether you are understood or not. At least, even though your answer is wrong, no problem. But try to respond. Everyone respond, please. No, I didn't get any responses so far. 48 students are there in class. I hope you are listening. Even though your answer is wrong, no problem. Okay. Okay. The question again I'll ask. I'll show you this program. Okay. This numbers, number one, number two, I am reading here. Okay. So in this place only I am reading. Why I am not reading here in this function or in this function or in this class? Why I am not reading in some other place? Because these are member of the add. Because program starts from main is actually I written this is main. But if you observe any textbook or if you observe any okay programming task, you didn't know. For your understanding only, I am using the word main. But in general, there is no concept of main in Python in general. Because we have to enter the numbers after the inheritance. Program starts from main. Okay. Any other answers? For example, instead of writing here, this instead of reading these numbers here, can I read these numbers in this class? Can I read these numbers in class A? Okay, can I read these numbers? This number one, number two. Can I read here? If I read here, what will happen? In class E, can I read? If I read in class E, then what will happen? If I read that numbers in some class, then what will happen? Any other answers? So main function, okay. For example, if I remove that main is for your understanding, I'm writing every time actually, because that numbers will belong to that class only. Okay, that is partial answer. But can you explain little bit more? Dhanush Kumar, your answer is correct only, but can you explain little bit more? Any other answers or someone can explain little bit more? For example, if I read number one, number two in a class 5 or in class 4, then what will happen? Numbers will belongs to that class only. Okay. So the reason again, okay, I'll tell you the answer. The reason why I'm reading that numbers, number one, number two there, because already I told you, if you are going to define some class, it doesn't give anything. That is definition only. After completion of all the classes, if I'm going to read anything, that will be comes under a global. Okay, so now I want to use the same number one, number two in all the classes. So that is the reason why I'm not reading that numbers in each and every class. I need to read in a global place. So once I read in global place, I can use it in any one of the classes. If I read only in class 5 or class 4, then again I need to read in other classes also. That's why instead of reading the numbers in each and every class separately, I'm reading that numbers in one place. The same numbers I can use in all the classes. That is what we can call it as global variable. If I read only in class 5, then there becomes a class 5 variables only, or we can say there becomes a local to class 5. I can't use in class 4. That's why I am reading the numbers in a common place. That is what we can call it as global. We can call it as global. Okay. So that's it for today. If you have any doubts, you can ask me. Anyone having any doubts?